Okay, so let's talk about ionic bonding. And so when we talk about something that's ionic, what we've said so far is typically we're dealing with a metal and a nonmetal. That you're going to take a cation and an anion. So metals are going to be our cations. Remember, cats are positively charged. And your anion is going to be typically your nonmetal, and that's negatively charged. Okay, so somebody's going to give the electrons and someone's going to take it. Now, you've got two different things. You have binary ionic, which bi means two. So it would seriously just be a metal and a nonmetal. So two elements and then metal and nonmetal. All right, so what we're going to do is we're going to start by naming them, and then we're going to just try to write some formulas from the names. So let me give you NaCl. All right, so the rules for naming binary ionic is you name the first substance. So the first substance is sodium. Okay, you look at the second substance, and the second substance is chlorine. But since it's no longer chlorine and he's married, he changes to chloride. So rule number one, name the first element. Okay, name the first element. Rule two, change the second element. So the second element will now get changed to end in ide, so sodium chloride. Third rule, you're going to check for Roman numerals. Okay. I don't have my periodic table loaded here for me right now, but how to check for Roman numerals. If you look on your periodic table, in the top right-hand corner, you see that sodium is just a positive one. That means he only has one possible way he can combine, giving away one electron. This does not require a Roman numeral because he only has one possibility. So this one does not require any Roman numerals. You're done, sodium chloride. Let's try another one. Let's do this, MnO2. All right, so two elements. One's metal, one's nonmetal, so it's binary ionic. So I name the first element. That's manganese. There is a difference between magnesium and manganese. Make sure you look it up, okay? Second element is oxygen, but it's going to get changed to oxide. All right, checking for Roman numerals. When you look on your periodic table, in the top right-hand corner, you'll see possibility of a 4 positive and a 2 positive, and maybe some more just depending. The periodic table I've given you guys has a 2, a 3, a 4, and a 5, and a 7. Most of the time it's just 4 and 2, okay? So we know this is going to require a Roman numeral because there's two options. So here's how we do it. We look at the substance not in question. Oxygen's not in question. He's always a -2, and I find that on the periodic table. So if -2 is happening twice, there's 4 electrons right here being taken. That meant this guy had to give 4. It's manganese, IV, so 4 oxide. So I'll say that again. I look the charge up on the one not in question, which is a -2, always a -2. 2 times 2 is 4. That meant manganese had to be 4. Okay, let's do one more here. So let's go Fen. 2 elements, so binary, metal and nonmetal, so we know it's binary ionic. Name the first substance. Iron. Second substance becomes ide, so nitride. Okay, all right, so now I look up on iron, and on the periodic table, top right-hand corner, it'll say 3 positive and 2 positive, so he does require a Roman numeral. So I look at nitrogen. He's a 3 negative. Notice I have 1 nitrogen and 1 iron. So if he took 3, he gave 3. It's iron 3 nitride. Okay, so these are binary ionic, writing the names from the formulas. Now, what I want to do is I want to go the other way for a second. Oops, yikes, sorry. I want to write the formulas from the names. We'll do a couple of these, and then we'll stop this video and give you another video for polyatomics. All right, so let's say I give you calcium chloride to start. All right, so calcium, I'm going to look him up on the periodic table, and he's a 2 positive. Chloride was chlorine before it bonded together, and he's a -1. These two guys have to match up. So if he gave 2 electrons, I'm going to have to somehow take 2 electrons. It's the least common multiple, okay? So it takes 2 chlorine. So 1 Ca and 2 chlorines, CaCl2. Remember, the drop and switch method, not a big fan of it, but if you have to do it, this is essentially 1, so it's -1. 1 comes down, 2 goes down. Ca, we just don't write the 1, Cl2. So you can mathematically do least common multiple, or you can do the drop and switch. Let's try another one. Let's do aluminum oxide. Aluminum, if you look on the periodic table, is a 3 positive. Oxide was oxygen, who's a 2 negative. Math-wise, the least common multiple is 6. So it takes 2 aluminum, 2 times 3 gives me 6, and 3 oxygen, 3 times 2 gives me 6. We're balanced. Or drop and switch. Okay. Last one. Let's go lead 4 sulfide. Okay, as we talked about in class, remember the Roman numeral tells us the charge. It's not the subscript. I repeat, it is not the subscript. It tells us the charge. Sulfur was a 2 negative. Closest number these guys have in common is 4. So it takes 1 Pb and 2 S's, because 2 times 2 is 4. This is the chemical formula for lead 4 sulfide. If you would drop and switch, you would have ended up with Pb2 S4. Not right. So if you're a drop and switch person, look and see if the numbers that you wrote down can be reduced. If they can be reduced down, now you have the correct chemical formula. Okay, so this is binary ionic. It's writing formulas from names and writing names from formulas. The next video will be with polyatomics.